So thank you for everyone for coming. Yep. And today I will share knowledge about IPFS and the Filecoin. So today is about the storage decentralized. So do you know that every data in the world, Facebook, YouTube, and everything actually is on the hand of some of the company, the big company. For example, the AWS. For example, your image, your video from YouTube, from Facebook or something, or Chinese company. So if one day data got blocked, that is your photos, that is your information, and maybe it disappear actually. So that means who is responsibility, who own that data? That company own data, right? It's not yours. So that is come to the problem that how we can decentralize for the storage for the data. If we want to do the NFT platform, if we want to do something that decentralized, that you have a token to buy something, and after that your image, your NFT image is not yours because it's maybe you hosted in the AWS, and in the end you didn't own it. Okay. Have the is private fair lectures. Yes. Okay. So this is the fundamental that every image or the files is a location-based address. For example, if we have the www website.com/asset/abc.jpg that is located to the servers. That means when you want to get that image, your computers will search for the IPs of the servers, right? So that's why it's called for the location-based address. That tell computers to where to get information. But if server go down, you won't get that photos. So that's why we have the solution nowadays that there is one guy that invent this technology that's called interplanetary file system, that they use the P2P technologies, P2P peer-to-peer technologies, same as a BitTorrent. Try to, hey, instead of the computer or instead of the files is hosted in some company servers, why not we use a P2P system that same as the BitTorrent, that everyone in the node can hold for the files, and it's the distributed storage for the network. Okay. So that's why we have to take a look back a little bit, that we have a location-based address that we want to get some photos. We have to search for that IP. For the IPFS, let me click mute a little bit. Wait a second. Okay, good. So for the IPFS, they use another system actually. The system called content-based addressing. Okay, so instead of you want some photos or the videos, you ask for, hey, I want to get abc.jpg. Where is my image? From which servers? From which IP of the servers? Maybe that server from the Facebook, maybe that server from the Amazon or the S3 storage. For the IPFS technology, you just ask, hey, who has this image with this hash or with this name? And this name is a HG79SFDTF, and ask in the network that hey, who has this file? Please give it to me. Okay, and some node, because we use a P2P, right? P2P or the peer-to-peer network, same as the BitTorrent technology, and some node that hold that file will give the file to you directly. Okay, that is how we can distribute that for the storage. And we can take a look for the example. And this one for the content-based addressing. Okay, So the identity of the hash file or that file, because we use content-based addressing, one thing that we need to know that something called CID. CID is stand for content identifiers, and it's the located for the files. Okay, we don't know who hold this file in the node, but if we call for this name for the CID, hey, I want this file, please give it to me as in the network, and someone in the network will give the photo to you. Okay, let's open this file together. Second. Okay, so if you, I can give in the chat. Wait a second for this file. Everyone can open this file together. So you can see this one is a network for the IPFS.io. And you ask that, hey, I want these pictures. Can someone in the network give it to me? Okay, and we don't know who is owned, who own this image. We don't know which IP, but the network will give it to you directly as a P2P technology. Okay. And I can share screen again. Cool. So, and for the CID, so the hash value or the name of the image is called CID, content identifier. It contains two things for the codex of the data, and for the multi-hash. This for this section, I will share a little bit 50% of the developers that if you want to learn more actually. So there is two things in the content-based addressing that we need to know codec for the data, how to encode for the data, how we can decode it. And the second one is multi-hash, that what is a hash type and what is a hash value. Okay. So next, for the IPFS object, okay, one object, because we want to store in the network as a node, right? So IPFS object, there are two things in the block. I mentioned it's a block because it looks like a blockchain, but actually it's not a blockchain. Okay. So IPFS object, there are two things. First is the data, and second is the link. The first one, the data is maximum as the 256 kilobyte. Okay, if you want to store for the hello world or the image that less than 250 kilobyte in one block, it works very well. Okay, and if we have some files or if we want to store for the videos that have more than 256 kilobyte, how we can do that? So this one is how we can handle for the image or video more than the 256 kilobyte, that we want to split the data that less than 250 kilobyte in the object, in different objects, and we link together. So that means if we want to call the object or that image, we want to call for the hash for the first one that have the link for every file in the node. Yep. This is how we can handle for the image or the video that have more than 256 kilobytes. Oh, okay. Thank you, Fabian. Okay, next. How about if we want to change the image, if we want to update on that hash, how we can do that? So there is something called versioning, that we can have the version of the file, and it will link which is called for the commit for the object. So if you have a new image, it will create for the new IPFS have the new link, and there is one specific thing for the versioning, that you can have version 1, version 2, and version 3. And next, so we can do inspection together. Okay, this one, because we learn for the CID, for the content identifiers for one object. And yeah, we want to look at how it look like for the data. Let me open for you guys in a second. Okay, cool. Can anyone confirm that you see the browsers here for the IPFS that have the inspection? Oh, good. Yeah. So you see that for the inspect. So you can see the first one that they have the CID or the name of that file. This one is hash. Hash is something that is a unique cryptography. When you do for the computation, you want to change from the big amount of the data to small size of the file, and it will return for the one string that have a unique. That is called for the cryptography, and it's called hash. So you can see that you have the CIDs, and you have for the human readable CID that that is called for the base 32. And I think this one is the multi-codec. Yeah, they have the codecs, and they have the char to dash 256. That is the hash, and the last one is a hash name. Yep. So you can see how it works in one IPFS block or the IPFS for the object. Yep. Okay, this one for developers who want to learn more for the IPFS. Okay, we continue. So if one node is go down, because we rely on the node, right, for the peer-to-peers. So if one node go down, what's happened? That node have my image, right? So when I ask, hey, I want to have my image, I want to see it, I want to download it, but that node already go down, what's happened? How we can prevent that? So for example, maybe we want to make the copies, and maybe we want to create for the incentive for the node that, hey, please keep the maintenance for the node. I will give you for the incentive, please store for the files. So because IPFS is cannot cancel for the copy, but how about the incentive? Someone that create the node, what is the incentive for them? So that is a problem, right? Wait a second. Good. Okay. So because we want to let for the network, for the IPFS network is more reliable, maybe someone cannot turn down for that node by themselves. We want to give them for the incentive, and that's why the who invented for the IPFS technology, or the same guys also invent the new technology called for the Filecoin. They use the blockchain technology plus for the IPFS, try to give them for the incentive, try to create for the storage market. Someone have the chat. Okay. Good. So I want to say for the overview first, for the Filecoins, it's super easy that you, as the users, as you guys as a users, you have one file, and you can give to miners with the fee. You have to pay something. It's not for free. Okay, so you pay something with to miners, and miner will keep the file for you. And there is a market that, hey, my miner will say, hey, for this this amount of the storage, maybe 32 gigabytes, you have to pay for this amount of the token, and they will store for the file for you in the period of the time. Okay, and if you want to download the image back to your computers, you need to pay as well to give fee as well, but the fee is super low. Okay, so you will understand this is how the mechanism of the Filecoin work. If you want to store for the image or the videos, you have to pay for the fee, and you have to pay for the price for that storage. If you want to download it, you have to pay for the fee as well. Okay, and that is how we can make sure that our file is have someone still keep it, instead of you pay for the Amazon for the S3, and it's rely on some companies, and that company have to do for the advertising to get revenues, to keep for the payment, to keep the expense for the servers. We can decentralize for the everyone for the node or the servers that owned by users, and you can propose for your storage and call out for the price of the storage. Yep. And you can earn some token if you have that computers and open a node in the Filecoin. Okay, and let me talk about how it works. The first one, that if you want to store for the file to the node, you have to pay for the Filecoin token as the vouchers in the payment channels. Okay, it's not paid directly actually. This one I want to talk in the technical a little bit, that they use something called the payment channels, that hey, I give you the money after FIL token as a voucher. If everything is done, everything is committed or already created for the hash and connect to the blockchain, at now in the blockchain. So you can get that vouchers, you can claim on that money. Okay, they use something technology called the vouchers in the payment channels. And for the storing data, there is some specific type of the data that they need to convert. They convert from the image or the video to .car files and store in the node. So that means users give the token and give the file to the servers or someone node, and that node change to the car files, and after that they have to do for the computation and create the hash. Okay, and it will produce two things. That is a COMD and COMR. Just I will explain in the next two slides what is a COMD and COMR. It's a computation or hashing for the proof of replication, that we make sure that we have replication in our node. Okay, and once you have that computation finished, it's very heavy computation actually, and you have to commit it in the blockchain. So in the Filecoin, they use for the two consensus algorithm. First one is the proof of replication. Okay, that this consensus is mean they want to check the data and replication in the node. That makes sure, hey, you have to copy the node, or you have to copy the file in your node. The second one, proof of space time. That means we have to check for the proof of replication over time. Over time, that means how we can make sure that files still existing over time. Okay, there are two proof consensus in this case. And this is how it works. So the Filecoin also avoid for the wasteful proof of work. They don't want to use for proof of work. They just they allow the miner to win the block reward by storing for the client data. And the proof of the replication is the proof that miners or the who own that node has the correctly generated a unique replication of some data. Okay, that data is the raw data that contains for the unsealed sector that they use the hashing cryptography, something called SNAC. This one that called for the ZK SNAC. That is the technology for the hashing. This is how it look like for the COMD and COMR. The first one is a data commitment, and the second one is a replica commitment. So what is it actually? So you can take a look on the left hand side. For the someone that is interested in a technical keyword for the blockchain, there is something called for the Markov tree that they will connect the hash in the hierarchy as a tree, and they will combine it together. Because it can increase for the difficulties of the hashing, that it prevent for the re-engineering or the for the hash. Okay, it's going to create difficulty actually. It prevents someone that want to regenerate for a new hash. Yep. So they try to connect every hash together, and that is called for the Markov tree. Yep. If you want to search later. So if you see something like this, it looks like a tree. So it just connect for the hash. And the first one is data commitment that you have for the .car file or the payload, and you connect it for the Markov tree, and you hash it for the unsealed CID or the content identifiers. Okay, once you finish, you have to seal it together for the sealed data. That is called COMRs or the replicas commitment. And this to hashing cryptography use CK SNAC. Okay. And what is CK SNAC? CK SNAC is a hash algorithm, or it's very heavy for the slow computation for create hash. If you have data for the 32 gigabytes and you want to change for the hash, it can change the hash to the 32 bytes. And the good thing of this one is that it can be verifying without relief data, right? So this feature is very important for the data because we don't want other people to relieve for the data, and it requires the heavy computation for the hashing. Okay, and this hash algorithm is used in the proof of the replication and proof of space. And next one is the proof of space time. That this proof it will, how to say, not have to give for the challenge, that there is something called for the cryptographic challenge over time, maybe 24 hours. You have to solve the problem for the hashing and try to finish for the cryptography. If you have that file, you can solve it. If you don't have that file, you cannot solve. So it proves that over time, you still have that file existing in your computers or in your node or in your servers. Okay, and they store every data for the proof of the replication and proof of space-time in the blockchain. That means it's very difficult to crack or to hack for the hashing by proof of the space-time and proof of the replication. Yeah. And if someone interested that, hey, how can I provide my server or my computers and become one of the node of the Filecoin? What is the specification for that? I have the information for you guys. That the first thing that is requirement that in the website, you can see, you can search in the link on the bottom left below, that you must have for the CPU 8 cores, at least 8 cores, and RAM for the 128 to 256 gigabytes, but they recommend for the 56 gigabytes. For the GPUs, it is not proof of work that try to create the hash, but we still need the GPU to create the hash by the CK-smart hash algorithm, because we need for the heavy computation and create hash. And next one we need for the hard disk for cache. Someone use the chat. Yes, Fabian is really high requirement. And you need at least hard disk that have for the cache that they, because you have to change from the raw file to the .car file. So you need at least 1 terabyte for cache. That's for cache. And hard disk in that server on your budget, if you had 100 terabyte, is you can provide it to the market. Okay, so this is a requirement for the hardware. And calculate. Oh, I have the calculator for the node. Okay, so there are two things that have the income. For the ideals as the income, first, when you finish for the block, because it will produce for the block, and you are the node that store for the files and create for the proof of replication and proof of space time, and you have to connect for the next block as well. Okay, so if you commit it, and if you produce or mint for the next block, so you will get 22 FIL coin or FIL token. Okay, 22. And actually, if the market, if you have the storage and you call out and you mark for the price for the storage, you will get for that fee as well, or that price as well. So that means there are two revenue from the node. Open a node first, when you create a hash and you create a new block, it will generate for the token for you. The second one, you will get the money from the user directly from the vouchers in the payment channels. Yep. So there are two things. Yep. And if you want to see for the storage price, I have the link here, link for the Filecoin explorers. I want you guys to see one thing. In the end of the table, there is something called import price, and you see that every client or every user or every miner in the node, they call for the price as a zeros FIL token. Why it is zero actually? Because everyone have the competitive price, and everyone want to get reward from the create a new block or the 22 FILs. If I mark the price is very high or it's not zeros, maybe the user will pick someone that is a zero Filecoin. Okay, so that means right now because of the token, it's not mint, it's not generate a new token, or they have the 2000, no, it's not 2000, 2 billion token, and I think it's already mint around 500 million token. Or there are still a lot more of the token that they didn't generate the new one for the create a new block. So right now, in practically that every miners, you let you store for the file or for the video or image for free actually. So this is how it works. There is someone, hey, wonders, is the storage market that we can ask for the price, but right now it's for free because everyone wants to earn for the 22 Filecoins for the token for one block. That is a lot of money actually for 22 Filecoins. I think it's around 800 US dollars I think it should be lower right now. 85 coins right now. Let me check quickly. Let me check quickly. I think how much the Filecoin for the per US dollar right now. Use browser. Maybe 5 seconds. $38. That means $38 multiplied by the 22 calculators. $38 multiplied by 22. So yes, they will get around $836 when they create one block. That is a good money, but don't forget that. The requirement for the hardware requirement is a huge spec. I think it's a lot of the money that you have to invest. And right now there are 3,600 nodes or 3,600 competitors that the blockchain will randomly pick someone to create for the new block. So that's why you have the chance to randomly to get the 22 FIL coin. One divided by 3,600. There is a percent chance per 30 seconds, I think. Calculators. There is your chance 1 divided by 3,600 nodes. Yes, you have only 0.02% for each. I think 30 seconds they will create one block. So you have this percentage to create a new block. Yep. If you have one server and you already invest and you want to create a node in the Filecoin chain. Yep. So next, let me continue. So next thing, you can take a look on the block explorers. Okay, let me open it for you guys. So you can see how is the information for overall for the Filecoin chain, that there is a block height that they already connect for the million and 400,000, I think. Yep, around million. And they have the active miners. Oh, it's increased. I think last day I saw it is a 3,600. Right now it's increased to the 3,700. And block reward is a 22.6 Filecoins. Yep. So you can see and take a look. And there is a miner address that they have, or they generate for the 24 hours reward, 3,200 Filecoin per day. Yep. So you can see every details, and you can see for the block. Yep. I want you guys to see for the one block. You can click for the block ID, and you can see the detail actually. That who cross this block, you will get a reward for the 22 Filecoins, and it will random pick. Yeah, and you can see for the message list that there is information how you can store for the hash. You can see for the proof commit sectors. I think it's a COMD or COMR. It's related to that for the hashing that I teach you guys. Yeah. And this one is a submit Windows POST, right? This is proof of space-time, this one. And pre-commit, this one is proof of the replication. Yep. So this is how they can store. And you can see for the values, there is a fee here. I think there is a fee here that they can get some money by the vouchers in the payment channel here. Okay. So there is the how one block is produced. And for the developers, so if you want to look at the Filecoin, how it works in the coding, so you can take a look on the project Venus, and you can take a look on the spec.filecoin.io. Okay. And for the use case, right now we take a look on the use case that the Filecoin want to be for the backbone for the decentralized for the storage. And so there is a use case for that. Someone want to create for the tooling for the developers. And this one is an NFT.storage that you can create for the decentralized storage for the NFT for developers. So it's easier for create a CID or the create and choosing for the dealers who want to create for a new NFT. You can take a look on the NFT.storage. This one is really good. You can upload the data and it will upload to the IPFS. And next one is a Web3.storage as well. So it's the same thing that it help you to upload it and store the data in Filecoin. Okay. And next one, textile.io. So this one they want to bridge for the Filecoin storage between the Ethereum, Polygon, and Nears. This one they are very smart that instead of we use the Filecoin only, we can use IPFS as well as the hot storage. Hot storage is mean that we upload to the IPFS network as a normal way for the traditional way. Maybe one day that file disappears. Maybe one day that node is gone. So that's why it's declared as a hot storage. But if you want to move that file to the Filecoin, you can do it easier in the s3.tech. Yep. And last one, because I interested in the Filecoin because of this one, or for the Sinso.io. So I read the document. I want to research more. So this company, they try to create for the medical NFT and they can do for the market for the decentralized application that your data or your medical data can store somewhere in the blockchain. After that, you can sell it. It have your own values. That's why I said that the storage decentralized is really important because you have some data right now in the Facebook or in YouTube or somewhere in the servers, someone else servers. That means you don't own that data actually. Okay, and for the medical data, so you should own it. So this one use the Filecoin as a technology that is a decentralized for the storage and store on your medical NFT. Okay, and they create a decentralized application and create a market. That means in the future, your data for the medical data, it might be value for the researchers. It might be value for the doctors or the hospital. Yeah. And thank you. And this one is the last picture that we have the web 1.0 that we can read only. And this current right now is a web 2.0 that we use YouTube, Facebook, and they can do data analytics. Okay. And the last one, that we want to do decentralized for the web application, we have the MetaMask, and we learn for this section we learn two things about the storage decentralized, and it's the backbone for the Web 3.0 actually. Okay, so that's all for today. So anyone have the question? So if not, so have a good night. So see you next time. Yep. Bye bye.